Welcome to this poster, which is on a polymer-based detection of antibiotics in water samples. Now in figure 1 you can see how antibiotics are distributed throughout the water stream. So while we remove antibiotics via wastewater treatment, they find their way in the water via farms, via hospitals and via industry. And you can see that it's a very complex process. So as a solution, we propose to use a sensor which in a fast manner and directly on site can detect where these trace levels of antibiotics are. And we'll make use of molecularly imprinted polymers, or in short, MIPs. And the technology behind it is explained in figure 2. Compared to using natural recognition elements, you will see that these MIPs are inexpensive, they're much more robust, and are very versatile, so you can adapt them to a range of targets, including antibiotics and microorganisms. Now, we propose two different ways of two different readout methods to detect whether antibiotics bind to these MIPs. So in figure 3 you can see our thermal detection, and in figure 4 we propose optical detection. Well, what's good about this is that we can actually have a dual sensing platform where we can directly combine those two and have direct validation of our results. Now, if you look at the thermal sensing principle, you see it allowed us to detect beta-lactam antibiotics in the micromolar range. So while this enabled this detection, some of the drawbacks of this technology is that it's not a commercial device and it is sensitive to changes in the ambient temperature. So therefore we also looked at a much more straightforward method, which was based on a direct method where you could see a change in color when there was binding of the antibiotics. And this colorimetric sensing is a really promising alternative, but we still need to check whether it also works in the presence of other interference. So I hope you enjoyed this poster.